I was playing around with vase mode on my 3D printer, and I printed this object, a Koch Snowflake cup, for lack of a better name. In the process of producing the design, I did two things that I think are worthy of short videos. One is that I generated an STL file by hand, as it were. I didn't use a CAD program, but rather had my program, processing in this case, generate a list of triangles in STL format directly. The other cool thing is that this program used recursion, which is fun to play with in the 3D printing context. So I'm going to talk about the object I made for a bit here, and then make a short video on STL files and another quick one on recursive functions. So what is this thing that I printed? Backing up a little bit, the Koch Snowflake is a mathematical object that can be generated in the following way. Start with this equilateral triangle. Every time you see a straight line, in the next stage, you replace that straight line by a straight line with this little spike in it. So from here, here's a straight line. In the next stage, it's replaced by a straight line with this little spike in it, etc. And you keep doing that process. The mathematical object is the limit of that process. But as far as seeing it, drawing it on a screen or 3D printing it, after stages 4 or 5 or 6 or so, the little bumps that you add are too small to really see. So what is the object that I created? Well, it's a little cup that transitions through the stages as it goes up. I skipped stage 0 just for stability. I wanted it to sit stably on a table. So it starts at stage 1. Stage 1 is the bottom. Then at this level, it's at stage 2. And then at that level, it's stage 3. And then at that level, stage 4. You can see it maybe more clearly looking at it this way. The bottom is this. You can see the spikes forming. Then it's at like stage 2. And then it goes into stage 3. And then it goes into stage 4. One of the features of this shape is that if I take it and I scale it by a factor of square root of 3, the two pieces fit together perfectly. Although in reality, I mean, that's mathematically true. I did make this one a teeny bit smaller to account for the width of the wall, but just a little bit. And they do, in fact, fit together. And I can keep going around, adding these. One more. And the resulting shape is square root of 3 times bigger than the center one. And it's the exact same shape repeated. You know, this shape is the same as this shape is the same as the whole shape, which is a feature of fractals. You know, they're self-similar. So I have this. If I have another one the same size as the middle one, which I do, I can stick that in, and you could see how I could continue this pattern and cover the whole plane, tile the whole plane with these shapes. Here they are close up. What are they good for? What is their practical purpose? Well, maybe you could use it as a cookie cutter, you know, to make Koch Snowflake cookies. Or maybe you could use this one as a shot glass, but I think your drink would probably go all over the place. So really, what is their practical use? Like most of my 3D printed objects, well, yo que sé, déjame en paz. That means, I don't know. Leave me alone.